right, I think I will just start. Hello, everybody. Welcome to my talk about a way to enforce best practices in a Jenkins environment. My name is Dave, and I work at GoodCamp Studios, which is a gaming company in Germany. And the approach I took here was using static code analysis in order to analyze a Jenkins instance, in order to analyze pipelines we build up in our company, and to measure things, which it all sounds a little bit weird in the beginning, but I hope after this talk you might share the same idea as I do, and hopefully you think that this idea has some potential. The agenda is pretty much straightforward. First of all, I will tell you a little bit about GoodCamp Studios, about how we use Jenkins there. This leads us directly to the problem, to the goal, to the things I wanted to achieve by going this approach. We will shortly define best practices because best practices are a very general term and they're very context dependent. So we'll talk about some best practices in Jenkins, in pipelines, in job configuration. This already brings us to code analysis. We will shortly go over code analysis and why I think that code analysis might be a good tool to tackle this problem. And then we'll shortly go over the implementation. We will talk about some rules, some metrics, some nice way to display it in form of widgets, and in the end, some short outlook and alternatives, what else there might be in order to maybe do a similar attack on this. And in the end, I will show you a small demonstration about how this currently looks like. All right, GoodCamp Studios is a gaming company in Hamburg, Germany. It was founded in 2009, has at the moment roughly 800 to 900 employees. And this is a small snapshot of how we're organized in a team or in a structure organized way. As you can see, we have a centralized department. There are several development teams who are responsible for some core features. For example, features which are needed by all the games we develop, like registration, login, payment, and shop systems, and so on. And besides the centralized teams, I'm also part of it. One team in the centralized department is taking care of the build and configuration management in all the studios we have. So as you can see, GoodCamp Studios consists of multiple studios. The studios are developing games. So one studio not only implements one game, they implement the same games of the same kind in their studio. And besides the studios, we also have, of course, not only game development, we also have development teams who are responsible for general things like tracking, data warehouse, business intelligence. And what I basically want to show you on this slide is that the centralized team, especially the team where I work, which is responsible again for the integration stuff, at least partly, we're serving all these different teams in the company. And the way we're basically doing this is with 3 points. The first one is provide them with infrastructure. So we want to make sure that every development team we have in our company has their own Jenkins infrastructure because different games are using different engines, different tools, different techniques. So it makes much sense to provide them with their own infrastructure, especially slave-wise. The second thing we do is we want to provide them with some standard solutions. So we want to make sure that as soon as a new game comes up or as a new game is about to be developed, that it can immediately start going on the continuous integration track. So the most common standard solutions we provide is continuous integration. We want to, as soon as be able to make them, push them to their release, so that they're able to release something. We want to make sure that they're able to deploy something, be it to test or even live production environments. And we also take care of some smaller pipelines or some smaller job configuration like static code analysis and so on. And the third thing we do is consultation, but this mainly depends on the game teams. It depends on the teams, how much expertise they have there, what kind of people are working there. So this pretty much depends. The important thing to notice, as soon as we shipped out the infrastructure for a certain development team, they can use our standard solutions, but basically they're on their own. So they're pretty much autonomous, and they can develop on their environment how they demand, how they want to do it. Which already brings us to the problem. So the team I'm working in is very small. We're a handful of people, and we're dealing with a lot of Jenkins instances. We're dealing with a lot of stakeholders. So a lot of people who are using pipelines, job configurations, deploy, release, integration jobs through the company. And what we want to make sure, that they're using the standards we provide, and we want to improve those standards. So with all these studios, we want to make sure that as soon as we have a standard for, let's say, releasing a certain product with a certain engine, we want to make sure that the game teams are using it. And if they are not using it, there actually might be two ways. They have a good reason for it, and in that way we want to learn, we want to adapt, because maybe they found a better way, maybe they found a leak, they found something to improve. And this we want to learn, we want to establish in our standards and provide to all the other studios we have in the company. Or it goes the other way, they did something wrong, they misconfigured something, and we want to proactively consult them not to do so. So we want to ensure and support our Jenkins health. And in the end, what we want is to establish standard. And the way I pushed it here in this scenario is by enforcing best practices. So like I said, best practices is a very general term, and it's pretty much context dependent. What I understood in this scenario, what I put it here is that I gave it some thought, and basically we want to keep track of the provided instances we have in the company. And we want to keep track of the instance itself, and especially on the build pipelines. And especially when we talk about build pipelines, they're pretty much unique. Whoever would build together a build pipeline, it would, I'm pretty sure, would look different because everybody uses different plugins, has different experiences, and so on. So I put together that a build pipeline is basically just a set of plugins with a certain configuration. Or if you go with the pipeline approach or with the coding approach, speaking of configuration as code, you can also define whatever you want to do in code or in external scripts or whatever. But for the first implementation of the things I wrote, I was only taking care of plugins and how they are configured. So I was focusing on the usage, what plugins are being used, on the configuration, how are we using a certain plugin, and also the combination. This is what actually makes like everything you need, because we most likely have a sequence of plugins we're using in order to define a build pipeline. And of course, we want to keep it simple, we want to keep it clean. Like I said on the slide before, we want to use our standards we provide and want to push them. And we also want to learn from the mistakes that the studios made. And we want to detect possible weaknesses in the job configuration in order to keep the environment clean. For example, we want to prevent polling happening in the game studios for performance reasons. We want to use the log rotator plugin in order to keep the disk space on the master always clean and stuff like that. This brings me to code analysis, why I thought back then that code analysis might be a good approach to tackle this problem here. In the beginning of this year, I wrote an article. I linked it even on the slide, but unfortunately, it's not visible, I guess. But the slides will be shared. And we don't even have to go through, so the article was about the top 10 reasons why you should use static code analysis. And I was not even really reading it because code analysis is old. We're using it, it's great, sure. And I already knew why it was great. But when I was scrolling through this article, it was clear to me that this is the reasons why you should use code analysis might also apply to this project here. We really want to understand the applications. We really want to understand the pipelines and the instances we have provided in our company. We want to keep the code simple, sanitized. We want to detect errors before they harm anyone or before someone else detects them. And we also want to see if the latest standards we provide are being used in the games or in the development teams. And of course, we want to improve performance. While reading over all these top reasons to use code analysis, it even came more clearer to me when I replaced some words here, because in the end, I made myself clear I'm not developing an application, I develop build pipelines, and I'm doing it with the help of job configuration, which in the end might also be code, again, talking with configuration as code. But when I was replacing the word application with build pipeline and the word code with job configuration, it made even more sense, because I really want to understand the pipelines the games or the development teams are using. I want to keep the job configuration simple and sanitized. I want to improve the pipeline performance. I want to see if it applies to the latest standards we have. and so on. In that case, it was even clearer to me that this might be a good fit. So talking about talking about the tool which I was using. So the tool we're using in the company is SonarQube, and I don't want to make specific advertisement for this product here. The main reason why I used it, that it was already established in the company. It was already being used for several projects, for several languages using static code analysis. So I made use out of this. For those of you who don't know SonarQube, it's a software quality management platform. It provides you with some rules and some metrics you can run over your project, and you can apply to this and see if they violate in something. You can measure stuff. All the things, the results of the analysis can be displayed in some nice widgets. You have some customizable dashboards for it. You have timelines in Sonar to see how your project behaved over time. You have some alerts you can put in some certain thresholds in the order that as soon as your project has a certain number of violations, or there's a violation of a very, very certain rule, you can get alerted immediately. You can cross-compare projects in this Sonar instance. And the most important thing for me back then was it is extensible. And so I started to writing a plugin for Sonar, which we were using in order to analyze our Jenkins instances, in order to analyze our build pipelines. And whoever of you came across SonarQube before, it's always addressing, or it's advertising that addresses the 7 axes of code quality, which are pretty much similar to the slide I showed you before. So it's all about coding standards, finding potential bugs, finding duplicated code, measuring complexity, and so on. And there again, I wasn't sure that this could be the right path to tackle this problem. So, like I said, I wrote a plugin for Sonar. I will shortly talk about the implementation. We will talk about the what we're going to analyze here. We're going to talk about where we are going to analyze the stuff, so where we're putting our input files. I will shortly show you how we do it, at least in some pseudo manners. And in the end, the why, what we can do with the information we got from there, and how this whole looks like. This will be partly explained in the slide and partly in the demonstration afterwards. So talking about the what. Usually when you do static code analysis of your project, for example, you have a Java project, you have some certain source files, for example, some Java files. And Sonar immediately knows, all right, these are Java files. I will analyze them with my Java rules, and we'll see how the project will behave. Do I find some violations? With Jenkins job configuration, it's the same, but a little bit different. When the first implementation of this plugin I wrote was only concentrating on config.xml file, because whatever kind of syntax you use, however you define and configure your jobs in Jenkins, it will always result in a config.xml file. So this was my first approach. Of course, now with Jenkins 2 and with pipeline, things get a little bit more complicated. Thanks for that. But it also, it has good reasons, and it should also be considered. So you might also use pipeline scripts. You might use pipeline script in your repository. You might use pipeline script defined in your Jenkins configuration. You might also use the workflow libs, so the Jenkins Groovy script repository, which also comes as pipeline. Or worst case scenario, you also have some external scripts where your build is being defined. And all of this needs to be taken into account. The good thing about the config.xml and all the pipeline stuff is that they're all in the same place. They're all in the Jenkins root folder. And this fact I used here for my plugins. For example, on your Jenkins root installation folder, the config.xml files you find under the jobs folder, the Groovy script repository for your pipeline extension is in the workflow libs folder. And even if you build your job on a slave, and the pipeline script is part of your repository, it will still be stored on the master. So this is the fact which I actually used here, that all the configuration files, everything which is important to analyze, is in one place. About where we analyzed it. Like I said, I used Sonar. It was already established. It's extensible, and it behaves on many levels like Jenkins. It's written in Java. It's open source. It has some core functionality, and same as in Jenkins, it's really big. The big power of it comes from the extension of plugins. And this is basically what I did. Again, similar to Jenkins, Sonar offers some extension points which you can override. And plugin development for Sonar goes roughly like this. You put everything you extended, put it in one plugin, deploy it on your Sonar environment, and you're basically good to go, basically. So I will shortly talk to you about the extension points I used, which were important in this case. The first one is we have to define a new language because we're not using a classical programming language like in the usual way. So we don't have a Java project, we don't have a C# project, we have a Jenkins configuration. So the major points to take into account here is on the one hand the key. So in Sonar, every language needs to have a key, which is basically the identifier. I just called it Jenkins, no problem. The second thing is taking care of the file suffixes. Like I said before, when you have your Java project, you're usually taking care of your Java files. And with back to the what we have, like the config.xml file or the pipeline script, that doesn't apply here. So because, for example, with the config.xml files, we only have XML files. But with the pipeline scripts, we don't know what we get because the default Jenkins file, for example, doesn't have any file suffix. Or you're using Groovy scripts, so then you have the Groovy extension, or you want to use something else. In that case, the way I dealt with that was basically that I accept any files, which I basically throw all these configuration files at Sonar and let the plugin decide what to do with these configuration files. But this I will show you in a second. Second extension, quality profiles. By default, you have to map some rules and some metrics to a certain language. So as soon as you start analyzing something, you don't want to configure something in Sonar and building your project together. You want to immediately be able to start some analysis. So this is basically just a mapping from some rules and some metrics to a certain language. This has nothing complicated to it. It's getting more interesting talking about the sensor. The sensor is an extension point where all the action actually is happening. This is where my plugin gets basically all the input files, get all the configuration files. And this is basically where we need to start trying to work things out. I'll put a little bit of pseudocode here. So we have this analyze method, which we need to override, which is from the extension point. And what we basically do here, the first thing we do is sorting the files. Like I said before, in the moment, I'm throwing all the input files at Sonar and let him decide what to deal with it. With the what, you know that possible configuration files are the config.xml files, the pipeline scripts, and so on. And what we basically need to do is to map a certain, we need to find out which config.xml belongs to which job, and which pipeline script belongs to which job. And we want to know which scripts of our central Groovy script repository are also being used in this certain job configuration. And this is what we're doing here. The second thing we do, so once we figured out, one more addition. So just imagine we have some very simple class job configuration which contains the name of the job. It contains the config.xml file, which we can easily parse with all the possible ways of Java, an optional pipeline script, and also optionally a set of Groovy scripts. This is at least roughly the current implementation. As soon as we have figured out where all these config files were coming from and we map them to a certain job, we can start collecting the metrics about it. So we'll iterate over all the over all the metrics we have. I will come to that in a second. Let them run over all the jobs, and then we can measure stuff. But this I will show you in a second. Rules, of course. We need to define some rules, the things we actually want to check. There we need to take care of two methods. The first one is the validate method. Oh, actually, I forgot in the slide before. On the sensor, the last thing we do, of course, is run the rules on the jobs. So we iterate over all the jobs and apply the rules on these jobs, depending on what kind of quality profile we're having, and then we're validating it and see if there are violations, which brings us to the rules. The two methods, validate and create violation. So the validate is called from the main entrance point, from the sensor, and there we basically can do whatever we want in order to create a violation. The create violation basically can be applied to every configuration file we have. There we can additionally say, in this line of code, we have this violation. Please put this message to this violation, and everybody who uses later Sonar will have access to this. And how you define the validate, it's completely up to you. I have some example rules there. You can even ask in the job configuration, as soon as the config files are sorted out, what kind of job do I have? Do I have a freestyle job? Do I have a pipeline job? Am I using multi-branch pipeline job? And then you can take all the configuration files you threw at Sonar and can try to figure out if a violation really is happening. Small example, for example, imagine you have a freestyle job and you want to prevent polling. So this example snippet here is part of your config.xml file. And in this rule, which should detect any polling job in your Jenkins instance, you basically override the validate method. You go to the parameter job config, get config XML file, and then you parse it, and you can basically access all the tags of this config XML file. And then you can see, all right, there's an STM trigger. It has some configuration. And at that moment, you know, all right, this job is polling. And then you can call this create violation method, for example. Metrics are there to measure stuff, to count stuff, in order to get a small overview about your Jenkins instance. Good examples would be, for example, you want to see how many jobs your instance have. You want to count how many freestyle jobs you have, how many pipeline jobs you're using. Or another interesting topic would be measuring complexity of your building pipeline, which gets a little bit more complex, especially when you have different job types. So I will come to that in a second, but I found out that it's hard to compare build pipelines which are completely written in freestyle and build pipelines which are written with pipeline, and it's hard to compare them on complexity here. Small example, in Sonar you can easily build this together with the metric builder. You define a key, which is basically a unique identifier. You give it a value, which is kind of a description, and then you say Sonar what you want to measure. So I put a small example here. I wanted to count the amount of freestyle jobs in my Jenkins instance. I built together this metric builder and give it the unique identifier amount freestyle, give it the description, the number of freestyle jobs I found in this instance. Value type is integer because I want to count something. And in the sensor analysis method, which I override, I just put the measurement, calling the metric, basically. Why we're doing this? So imagine we have this bunch of Jenkins instances out there. Each of them is calling the Sonar analysis on a nightly basis. And we want to continuously improve. We want to continuously improve our standards. And we want to see and measure what is basically going on there. So what we do is we analyze it. We configure Sonar in order to get alerted when a certain Jenkins instance in our company reaches a certain thresholds of violations, or if something severely, in our opinion, goes wrong, or we ourselves see it by analyzing the dashboards. Then we notify the teams. We approach the teams and tell them how we think there might be something going wrong. And there, like I said at the beginning, are two scenarios. They misconfigured something. They just fix it. We all go back to the analysis, to the next one, see if they fixed all the problems. Everybody's happy. Second scenario is they really fixed something for a very good reason. Then we need to improve. We need to adapt our rules. We need to adapt our standards. And then we can bring this adapted rules, because it's in a central instance, also to the other development teams we have in the company. That way, all the development teams we have in the company are kind of keeping up to sync and are using the same kind of rule set when it comes to plugin configuration, for example. Some example rules I put together. These are really just some examples, but the imagination here has no end. You can basically check whatever you can imagine checking in a config.xml file, in a pipeline script. Basically, what I did when I implemented the first draft is enforce plugins. There are two ways you can do this. You can enforce them always. Like, for example, you want all the jobs using the timestamp plugin because you love the timestamp and the console output, and you want everybody to use it. You can enforce plugins on a conditional base. For example, on configurational base, you want everybody to use the lock rotator plugin, but you not only want them to use the lock rotator plugin, you also want them to use the lock rotator plugin with a certain configuration. It doesn't make any sense if they're using the lock rotator plugin, but they're storing the last 1 million artifacts. And stuff like stop or prevent polling in the company. We also can introduce some naming conventions, so some naming scheme for a company. You can enforce everybody to use a certain pattern when it comes to job names. You can sanitize the job name, so you can basically enforce that no special characters are being used in your job configuration name, because some plugins actually may have some problems with special characters in your job name. You can even create some name plugin conventions. For example, in your company, you have a certain way how to deploy things. You can enforce that the job configuration name should or need contain the word deploy, and then you know, all right, if the job name of this job configuration contains the word deploy, I know that there's actually something with deploy happening, so there are no changes over time which might surprise us. We can prevent the system exit in Groovy scripts, nice. We can enforce that the dynamic time parameter age and the cron usage is actually being used. We can enforce distributed builds. In our scenario, for example, we don't want to build on the master because we have slaves for it, which are configured in a better way. We can enforce using labels for all the slaves. Even with the pipeline, there are some possibilities. We can check the size of the pipeline scripts in order to keep everything readable. We can enforce stages or checkpoints in pipeline, and so on. Basically, there are a lot of things you can do, and in the end, of course, it always depends on what you want. But the good thing about Sonar is you can, in the end, define which kind of rules you like, which kind of them you don't like, and then you can put together the set of the rules which fits for you the most. Even though if you only like one rule, like prevent or stop the polling, that's also a benefit you can get easily. Some example for metrics. There I haven't actually implemented that much. You can, for example, count all the jobs you have in your Jenkins instance. What I implemented so far is I can count the jobs types, which I will show you in the demonstration. So see which of the studios or which of the teams is using pipeline already, which of them is using multi-branch pipeline. You can even check if you can even enforce the rule that every repository you're using in Jenkins should at least one job which is using the multi-branch pipeline to enforce that. You can measure the repository usage. You can even detect job cycles or cron statistics. You can measure the amount of polling and triggering jobs just for performance reasons. Or you could measure complexity. Like I said before, it's getting a little bit difficult when you want to compare freestyle jobs with pipeline jobs. There is some basic implementation I already did where I can, for freestyle jobs, for example, you can measure the amount of plugins which are being used for this certain build. And you can measure if the conditional build plugin, for example, which make things more complicated. Or you can also take into account if you have a really long pipeline of chained jobs. It's not very good for readable reasons, so it makes things more complicated. Of course, when we're talking about code complexity and code analysis, we also might think of this cyclomatic complexity. So we need to take into account all the if conditions, all the for loops in the Groovy scripts we might write, which might things maybe hard to read. But this is like not implemented yet, but there are just thoughts, things which are possible with this. The challenges I had so far developing the state where the plugin is currently. So at the bottom it's open source. You can clone it, fork it, give me some suggestions about it, do it whatever you want. The challenges about the current state of implementation is basically that there are different versions of plugins who handle configuration a different way. So it hasn't occurred to me yet because all of our Jenkins instances are in sync, but this might be a problem for other instances. For example, there are two Jenkins versions who are using the same plugins, but in a different versions, and the different version of these plugins, they configure the same thing in a different way because someone changed the API. This also needs to be taken into account here. And the only way you can actually tackle this is by using this continuous improvement cycle. There are, of course, different ways of implementation. There are different ways you can implement the same behavior of a build pipeline. This goes the same along with different ways of configuration, especially with pipeline. You have a lot of flexibility to do whatever you want with your pipeline. And in code, you can do the same behavior in a lot of different ways. So things are not getting easier here, at least analyzing when it comes to standards. But of course, on the other side, you can have cyclomatic code complexity. On the other side, there are a lot of things which you actually could do in the future, or things which are possible. For example, including global configuration. For example, like in the keynote, what was mentioned there, when your Jenkins instance is this car of plugins, and you want to see what kind of plugins are you actually using, and if this car is still running. You can measure with Sonar, are there maybe some plugins who are violating each other or who are in conflict with each other and could harm problems. Or for example, if you're using the SSH plugin, where you define all your SSH targets in your global configuration, the Sonar plugin can actually check if these targets are being used in your job configuration. And this way you can detect some old test servers or some machines which are not being used anymore. Additional to that, you can also include some builds and their results. This might come in handy when you want, for example, you want to find jobs which have not been used or been built for a very long time, and want to detect them because they're maybe polling for no reason or they are there for no reason. Which brings us to the demo. Oops. So this is a local Jenkins instance I have. The only reason it is here that I can show you how we actually do is, so whenever we roll out a Jenkins instance for a development team, we provide them with already one existing job, which is the job which actually does the Sonar analysis. We run it on a nightly basis. Still have time. Sorry? Check. Wait, I don't have no German keyboard. 1 second. I try. I give it my best. Yes. Yeah, next year I will ask for the big room. So the reason I will show you is whenever we roll out a Jenkins instance, we provide them with already one job, which is taking care of the code analysis. We run it nightly, and we do it with the Maven. So the only thing we need to do is calling the Maven Sonar Plugin we're doing here. And as a POM configuration file, we put the POM file, like I said, in the what kind of files we're analyzing. They're all in one place. So this is actually where we inject this POM configuration. It contains what kind of language we have, called Jenkins, and it also contains what kind of input files we want to throw at Jenkins. And then we basically run for every Jenkins instance we have, we run this Sonar analysis, and we will end up with the Sonar dashboard. And this is just an old demo. So here you can see only 4 Jenkins instances. We have much more, but this should give you a small overview about how this can look like in dashboards. And you can see immediately, all right, these are the Jenkins instances we have. You can see the amount of issues we found on these Jenkins instance. And we see, for example, the Jenkins instance of the project Moonshots has the most issues. And we can narrow it down to technical depth. We can see that they have major issues in the configuration or minor issues. And we can just click on that. And we can see, the job description is actually very long. Oops. And we can see what kind of jobs do have which kind of problems. For example, here's the job, deploy asset bundles. And it's not using the lock rotator, for example, or the job Groovy scripts. It uses polling, it's not using the lock rotator, it's not even assigned to a node or label. So it violates multiple times our restrictions. So you can immediately see the amount of issues you have with your project. You can even go on the instance itself and you can click together your customized dashboards. So none of this here I developed, I just customized the dashboards we were already using. You can get an overview about an existing instance, like for example, the amount of jobs which are being used. So here you can immediately see, all right, this project is not using any pipeline jobs whatsoever. So here we might, as a centralized team, approach the team and talk about some conversion to pipeline, for example. Here's the initial approach of measuring complexity in build pipelines. It's pretty simple, but what I do here is basically adding up the complexity of all the jobs. We can click on that and we can see what job has the biggest complexity, at least according to my rules. Like I said, this is very simple. And then we can also compare the jobs on one instance, and we compare the jobs through the whole company. And this makes it pretty good for us because we can see, all right, this project, they're using an integration job which has a very large complexity. And then we can compare to another instance. And then we can find out why that is. Maybe this is for a good reason. Maybe they improved something on a very big manner. or maybe they just made things complicated for no reason, and then we can roll back there. And then we can compare all the jobs. The quality profiles you can see here. Like I said before, the default profile is already implemented in the plugin. It contains currently 7 rules. And there is this repository of rules where you can basically add rules to your repository. So whenever you would like to start with that, you can even remove them here, or you can even change their importance. You can browse through all the rules and see which of your Jenkins instance is violated by this rule the most. For example, the Moonshots instance again, they're archiving in 35 jobs more than one build. And usually in that kind of game, the artifacts are getting really, really large. So this might up ending having some disk space problem on the master, for example. Yeah, what else to show? So basically, you can put together your set of rules, your set of metrics. It's automatically being put to Sonar, and the way how you deal with the metrics and how you put your dashboards, it's basically up to you. Let's back to the slide. All right, yeah, this is it for the demo. Thanks for joining, and I think next are questions or questions. Thank you. Yeah? The question is if this plugin already supports new pipeline DSL. Partly, it already has the implementation in order to read the pipelines, but the biggest problem is here parsing the source code. I think you have basically 2 options: parsing it whatever possible way of Java, or you can go with the Sonar approach. So this isn't implemented yet, don't get me wrong, where you build up this abstract tree syntax about your language in order to go through it step by step. The way I used it so far is the simple approach by just parsing the source files in order to see if a certain plugin, for example, is being used or not, or to see how a certain plugin is being configured within pipeline. Yeah, but things will get complicated because you can implement the same thing in a lot of ways because you have the flexibility of Groovy and to do whatever you want. But for now, I'm sticking with parsing it with the help of Java. It will be needed, yeah, definitely. So the reading of the config files of the pipeline scripts is already there. The only thing which is missing, how to parse it, and this depends on the rules. So I already have 2 rules where pipeline scripts are being considered, but I will definitely have a look at the Sonar GroovyScript plugin, which parses GroovyScript files. Of course, it's only looking for syntax here, but they also might have a good way how to parse it. Yes. Basically, like I said in the beginning, the teams are autonomous. They can do whatever they want. We're just consulting them there. And for all the rules, or at least the handful of rules we have so far, we have really good reasons to use them, like, for example, to prevent polling. And there, actually, it's easy to convince them to do so. The biggest part is, like, who is doing it? Because a lot of instances, a lot of jobs, we can assist them of doing it, for example, with the help of scripts, of the script console, especially when you have to change a lot of jobs. Yeah, but it all depends on what you want to change and why you want to change it. But for the rules we're using so far, we have good reason to use it because we had some problems in the past, and we can show the teams what kind of problems the violation of this rule might cause. It's only a question of who in the end is going to implement it. And there is most likely both parties are involved because we want to show them and they want to actually implement it. Okay, the question is if I have a single Jenkins instance in order to monitor all the analysis. This is actually happening on the Sonar instance. So we have the bunch of Jenkins instances out there, and every one of them has a certain job, which is executing the code analysis. And by that, it's actually every analysis and all the data and the results of the analysis is going to the SonarQube dashboard. And there he's collecting the data for each of the projects. So each Jenkins instance we have is running a nightly analysis and provides the data to Sonar. And this is the way, or one of the ways, how Sonar can display it. Measuring the issues lets you browse them. But this is there's no extra Jenkins instance. Yeah, it's open source. It's on the last slide. There's a link. for performance reasons, and we want to use triggering because there's no delay. It's better for performance. I think this is a common thing. But of course, you don't have to use the rule. You can in Sonar say, yeah, but we like polling, we want to do it. Sure, you can put into the quality profile whatever rule you want to have. But for polling, it's out of performance reasons, yes. So the question is how we can we deal with Sonar with different Jenkins instances who might have the need for different rules, right? Because maybe one rule doesn't apply for one instance. This you can split in Sonar. So you can basically, when you run a Sonar analysis, you have your POM file, and then the POM file, the Maven coordinates are being used in Sonar to address this. And with the help of quality profiles, by default, everybody is using this default Sonar profile, but you can add additional profiles. And then you can say, all right, the Jenkins instance for this project should use this profile. And this you can also put in your POM configuration. And from that moment on, it will use its own set of rules. So you can have tons of these Jenkins quality profiles with different rules, with a different set. And that way, for every Jenkins instance, it behaves the same. Different. If you don't want to, okay. So the way we do it is with using the Maven Sonar plugin, because we're using Maven anywhere, but you can use any other Sonar possibility to run it. You can use the Sonar runner, you can use any other build system Sonar provides. This is just our tool of choice because I was used to Maven, I know how to configure it, I know how to run it, but you're free to use whatever you want. So the question was, can you use other methods to run the analysis than Maven? First of all, 5 minutes? First of all, you have to define how you want to deploy. This can be with the help of, so it depends on if you deploy in the code or using some special plugin. But usually, when you go to the, one second, if you go to the rule slide, you have this validate method in your rule. So there you can basically, you get the job configuration as parameter, and then you can call the job configuration get name of this job. Then you can parse, okay, does it contain deploy? And then get config.xml, get pipeline, you can see if actually something deployingly is happening there. But this pretty much depends on how you deploy. Are you using a certain plugin? Are you using, deploying from command line? This you have to catch there. For me, as far as I know, someone has to put the initial POM file for this Jenkins instance there. It has Sonar properties. At least we give the properties to the Maven Sonar plugin, and the Maven Sonar plugin is putting this as Sonar properties. No. It has nothing to do with the POM file of the projects. No. There's an extra POM file, and this POM file represents the Jenkins instance as an own project. But it has nothing to do with the projects. In the, it's like I said, it's open source, and there's an example POM file. You just have to put it in the root of your Jenkins installation, and you're good to go. And you have to exchange the name because you need to give it some proper naming. But you don't have to touch any configuration of the projects. No. Cool, so thanks.